You're welcome to this channel. If this is your first time of coming across this channel, kindly subscribe to this channel. Click on the notification icon to get notified when we release an insightful video like this. What are we learning in this video? This video, we are continue our learning journey on calculus. Today, we are going to look at application of differentiation. Now, how can we apply differentiation? Now, we are not going to look at every application of differentiation because differentiation find a lot of application in engineering, in economics, in many fields, applied science, basically applied science. So what we want to look at is what you'll be asked in your exam. The first thing that we're going to look at, what you'll be asked in your exam, is application of differentiation in dynamics. Now, we are going to look at extrema of function. When you have function in mathematics, you know that we have different functions in mathematics: trigonometric function, polynomial function, and the likes. They are extreme when you plot the graph. When you look at the function, the maximum, the minimum value, maximum point, minimum point. So we are going to look at that. Now we are going to look at another interesting application of differentiation, which is rate of changes. How can we model formulas? How can we model physical parameters that is changing with time? How can we use differentiation to solve the problem? Now, the first one is we are going to look at some concepts in dynamics. In dynamics, let's quickly look at displacement. Now, we all know that displacement is a change of position of object in time and space. The change of position of object in time and space is known as displacement. Okay. Now, displacement is a function of time because displacement of an object is taking place at an instance of time. Okay, that is displacement. So when you want to model a formula to find the displacement of an object in space, now just take note that that displacement is taking place in time. So that displacement will be modeled along time. Okay, now we have another thing in dynamics, which is velocity. Now, we all know that velocity is the change of displacement to change in time. So, change of displacement to time is velocity. So, which implies that if the function of displacement is related to time, okay, then velocity can be modeled from displacement. So, which means that velocity will be what? Change of displacement over change of time. So when you differentiate the displacement function with time, so you are going to get velocity. Now we also know that velocity, looking at this, we have modeled velocity with time as well. Velocity with time. Now velocity is also a function of time. Okay. Now that knowledge, we can use it to find another thing again, which is called acceleration. Now if velocity is a function of time, then acceleration will be what? Change in velocity divided by change in time. So you are going to differentiate velocity with time to get acceleration. But yeah, come over here, look at this. dv with time, change of velocity with time. To find the differentiation, you all know that velocity is what? ds over dt. This velocity here is also ds over dt. Okay, when you put it here, you now have d dt outside. I'm talking about this. V here is this. Just put it. You are going to have d dt ds dt. When you expand this, you're going to get d square s over dt square. So d square s over dt square is an higher derivative. The second derivative of displacement function with time, we are going to get acceleration. Okay. So if you have a question, you are given displacement as a function of time and you're asked to find acceleration, is very simple. What you just need to do is you differentiate your function 2 times, and you get your acceleration function. Now, according to Newton's second law of motion, which is telling us how we can measure force, we all know that force is equal to mass times acceleration, isn't it? Force is equal to ma. We are come over here, and we know that this acceleration is dv over dt. What we can see here. So when you put it here, you have m dv dt. Now, this one is also Newton's second law of motion. If you are talking about rate of change of linear momentum, recall that dv means final velocity minus initial velocity, v minus u over t, and that is what? rate of change of momentum. Okay, so we can also state Newton's second law of motion using rate of change of momentum. We are not doing physics. Now let's continue. So dv over dt. Okay, now just like what we have done here, dv over dt is also d square s over dt square. So you now have mass multiplied by d square s over dt square. This is Newton's second law of motion. Okay, now let's see how to apply all this to solve some question very fast. The first question is the displacement function of a particle in meter is expressed as s is equals to 3t cubed plus 4t squared minus 10. Find A, the displacement after 2 seconds, B, the velocity after 1 second, C, the acceleration after 4 seconds. Before we rush into solving our question, let's quickly look at this question. We have displacement is given as a function of time. Okay, you have this expression which is a what? A cubic function, isn't it? You are asked to find the displacement after 2 seconds. So this is the displacement. You just need to put 2. Wherever you see t here, you can get your displacement very fast. Now the second one, the velocity after 1 second. This is displacement function with time. So you recall that velocity is what? Change in displacement over time over change in time, isn't it? So you have ds over dt. You can find that and you simply put 1 where you see t. So you get a velocity. The third one, you asked to find the acceleration after 4 seconds. You just need to differentiate this one twice and plug in the value of t. As simple as that. So let's see how to solve it very fast. So we are given displacement function which is s is equals to 3t cubed plus 4t squared minus 10. That is displacement function. Okay. Now we are asked to find the displacement afterwards after 2 seconds. Just go ahead and dump 2 inside this expression. So where you see t, you are going to have 2 there, isn't it? So the displacement after 2 seconds will give you 3 open bracket 2 raised to power 3 plus 4 open bracket 2 raised to power 2 minus 10. As simple as that. Okay, what is 2 raised to power 3? 2 times 2 times 2. So that is 8. I'm talking about this guy here. Now 8 times 3, you get 24. Okay, let's come over here. As this is what I'm saying. Here you have 2 raised to power 3. 2 raised to power 3 is equals to 8. Okay, I'm talking about this guy. So when you multiply 3 by 8, so you have 3 multiplied by 8 is equals to 24. Okay, now here you have 2 raised to power 2 is equals to 4, isn't it? 2 raised to power 2 is equals to 4. You now have 4 times 4, you have 16. Okay, oh yeah, let's combine everything together. So you have 24 plus 16 minus 10. What is 24 plus 16? You have 40 minus 10, isn't it? 24 plus 16 is 40 minus 10, then 30. Okay, you see that is very simple. That is 30 meters. So our answer is 30 meters without wasting time. Very simple question, isn't it? So 3 times 4 plus 4 times 4 minus 10, and that will give us 30 meters. So the second question, so we have to find V. So we want to find the value of V very fast. Now, we all know that V is equals to ds over dt. Okay, let me show you if you don't understand how we got 90 squared plus 8t. It's very simple. Just come over here. Differentiate this one with respect to t. It's very simple. So ds over dt. Don't forget, you bring out this power. I'm talking about this one. You bring it down. 3 times 3. So you reduce it by what? By 1. 3 minus 1. If you haven't watched our previous video on calculus, go and watch it. Expect you to know all these things. So we have plus 2 times 4 t raised to power 2. T raised to power 2 minus 1 minus 10. As simple as that. So we have 9t raised to power 2 plus 8t. Okay, this minus 10 here, I'm sorry about this. This is a constant here. So when you differentiate it, you get 0. So that is why we have 90 and the likes. Okay. Oh yeah, put the value of at t is equals to 1. So you have ds over the t is equals to 9. Open bracket 1 square plus what? Plus 8 open bracket 1. Okay. What is 1 square? 1 square is 1. 1 times 9, 9. Plus 8 times 1, 8. 9 times 8, you now have 17 meter per second. So you have 17 meter per second. Now to the last question, which is acceleration. We all know that acceleration is what? Second derivative of displacement function with time, d square s over dt square. So it implies that you are going to what? You are going to differentiate the displacement function twice. This guy here, you differentiate it twice. So this is the first differentiation, which gives us velocity. You will now use this one again. You differentiate it again. So you are going to get 18. You're going to get this guy. So that is the guy that you're going to get. Now, without wasting time, you just bring down 2. So you have 2 multiplied by 9, t2 minus 1 plus 8 multiplied by 1, t raised to power 1 minus 1. What is 1 minus 1? 0. T raised to power 0 is 1. So that is why you have this guy here. Okay. Now, let's continue. So at t is equals to 4, just go ahead and put the value of t. So you have 18 multiplied by what? 4. So you have 18 multiplied by 4. What is 18 multiplied by 4? That's 72. Then you put your unit meter per second square. Very simple. So the next question, which is a ball of mass 10 kg is moving with a displacement s is equals to 2t cubed plus 5t squared minus 8t. Calculate the force acting on the ball after 2 seconds. Neglecting air resistance, how can we solve this very fast without wasting time? It's very simple. You're given mass, isn't it? And then you're given displacement, you're given time. And you are asked to find what? To find force. Recall that using Newton's second law of motion, force is equals to mass times acceleration. So which means you just need to find acceleration out of this displacement function. As simple as that. Then you multiply it with your 10. So you can get your answer. Okay, now let's solve this. Solution, you are given the mass, which is 10 kilogram. All right, so mass is 10 kilogram. Then you are given the displacement, which is 2t cubed plus 5t squared minus 8t. Okay, recall that force is equals to what? Mass times acceleration, m dv over dt, and that is m d square s over dt square. So let's quickly find d square s and dt square. Before you find it, you find ds over dt. All right, ds over dt, just go ahead and differentiate this guy. Very simple, just bring down your 3 to the back. 3 times 2t, you reduce 1 by 1, it becomes square. 3 times 2t square plus, you bring these 2 down at the back. So you have 2 times 5, you reduce it by 1, so you have 2 times 5t. Then you bring the 1, which is the power of t here, you bring it down, so you have 8 times 1, then you reduce the power by 1, so that is t raised to power 0, and that is 1. 8 times 1, 8. So when you solve this 3 times 2 here, you have 6t squared. 2 times 5 here, you have 10t, then you have minus 8. Now the next thing is to find the other derivative, the second derivative, which is d squared s over dt squared. Okay, come over here, differentiate it once. 2 will come back. 2 times 6, you have 12t. Then this one is t, so when you differentiate it, you get the coefficient again, plus 10. All right, we have solved that, which is the acceleration. All right, what is force? Mass. You just want to use this times this, m multiplied by 12t plus 10. At t is equals to 2. Don't forget, in the question you are given time, which is 2 seconds. Okay, so just go ahead and plug in 2 inside that formula and the value of mass, which is 10 kilogram. So let's go. F will now be what? 10 coming from mass, and you open bracket 12 multiplied by time, which is 2 plus 10. What is 12 times 2? You have 24 here, plus 10. Then you have your 10 outside. What is 24 plus 10? That is 34. And you have 34 times 10. What is 34 times 10? That is 340. We're not given the unit of displacement here. I didn't think we are given the unit of displacement here. We will have put Newton. So since we are not given displacement here, we cannot just say that the unit here is Newton. So let's just put 340 force unit. Another application of calculus, extrema of function. Recall that in mathematics, every function we have exponential, trigonometry, logarithmic expression, polynomial, all the functions, they have a diagrammatical expression. So which means you can plot the graph either in 2D space or 3D space. Is either you draw a line if it is a linear function or other functions that are curve. Okay, now this curve, this line, they are going to have two extremes. Is either they have maximum points and they are going to have minimum points on the graph. So they are going to have maximum value when you try to take their limits or the minimum value. Okay, now these values are now called extrema of functions. So we are going to have two extremas. Now we have some function that has more than two extremas, but basically we are going to have two extremas. We're going to have maximum value, maximum points, and minimum points. So let's see what I'm talking about using this graph to explain something for you guys. Now let's have x and y axis as shown. So we have y axis, we have x axis. Okay, now let's have a curve. Let's just have this curve that is starting from the origin. Okay, now let's try to find the slope of this curve. Slope means differentiation. We want to differentiate this curve. So we want to differentiate the y with respect to the x. Okay, change in y over change in x, which is called slope or gradient. Now to find this, since this is not a straight line, this is a curve, you are going to draw a tangent to this curve. A tangent is a straight line that touches a curve and moves away. That straight line is not cutting across the curve. It's just touching it and moving away. That is what we call tangent. Now to draw a tangent, we have a tangent as shown. Okay. Now the next thing to do is we need to take angular measurement, because in coordinate geometry, when you want to find slope or gradient, it means tangent of the angle that is being made, angle of inclination with the horizontal position. Okay, now let's try to measure the angle. Just come over here. Let me just draw the angle over here. Let me bring out my pen. Now this is the angle over here. This is theta. This is angle theta. Now looking at this theta, we are going to see that theta is what? Theta is less than 90 degrees. So we can all see that the angle is less than 90 degree acute angle. Now to find the slope, the y dx is equals to what? Tan theta, and we are going to get a positive value. So which means the slope of this curve is positive. Okay, now looking at this curve as well, you are going to observe something at the terminal point of this curve, this point. Okay, now you see that at this point the slope is kind of changing. Okay, I'm talking about this point, this yellow point here. The slope is changing. Let's try to find the slope along that point, that position. You're going to draw a straight line like this. Okay, so when you draw a straight line like this, you know that the slope is now what? Is 0. The slope each time around is 0. Now at any point on a curve in which the slope, change in y, change in x is equals to 0, we call it stationary point. We call it what? Stationary point. Any point on a curve that the gradient is 0, change in y to change in x is 0, we call it stationary point. Okay, now this curve is continuing. Let's continue the curve like this. What do you observe at this point as well? The slope of this curve has changed from being positive to negative. Let me show you how it changes. We need to take angular measurements, isn't it, to find the slope? What you just need to do is you draw the angle like this, theta. Now this angle is what? Obtuse angle. Okay, tangent of obtuse angle, tan theta here, will be negative. Okay, the slope of that line is negative. Now we are come back here. Let's just come back here. What do you observe about this point? This point, the slope is now 0. Okay, now at this point, when you continue the curve gradient changes from positive to negative. That is why we can now call this point a turning point. This point is also known as what? Turning point. Stationary point and turning point, because the slope is changing from positive to negative. So at turning point as well, dy dx is equals to 0. Okay? Now we also have some other points like this. Now let's go. This slope is having maximum value here, maximum point here, and minimum value here, minimum point here. Okay? When you find the coordinate of those points, you are going to get y coordinate and x coordinate. Okay? So the y is minimum here, minimum value for this function, because this function will be y is equals to something or something like that. The x is maximum here, the y is minimum here. The y is maximum here, the x is minimum here. Okay, so continuing this graph, you also have some other points like that. That is called stationary points. Now, stationary point on a curve is a point in which the gradient is 0. That is, change in y over change in x is equals to 0 for stationary points. Now, we also have turning point. Turning point is a point at which the gradient is changing from negative to positive. Negative to positive. And turning point can also mean the point at which the gradient is changing from positive to negative. So it is vice versa. Now let's have some diagram again. We have a curve as shown. Now this curve is looking like a quadratic curve. Okay, when you look at this curve very well, you observe that this point will be the what? Maximum point. Okay, maximum point. If you have a U curve for quadratic function again, this point will be called minimum point. So it's having maximum point here, it's having minimum point here. Now, what if you now have higher function that is more than quadratic function? Let's say you have a graph like this, or you have a curve like this. So it's going to have maximum point, maximum value for anything that is on the y-axis, okay? Then minimum value for anything that is on the y-axis, okay? Minimum point. Now, we can have a curve that doesn't assume this kind of form. We can have a curve that is moving like this and moving like this, which means that the slope is not changing, the gradient is not changing. Okay, now but we observe something here. Now when you look at this curve very well, you observe that, let me show you something here. Let's go. At this point here, the concavity of this curve is changing. Instead of this curve to move like this and form U, it changes from the point at which it can form U to the point at which it forms N. So that is what we call point of inflection, when the gradient is not changing. It's not changing from positive to negative or negative to positive, but the curve is changing from being concave to convex or from being convex to concave. That point is now known as point of inflection. Point of inflection. So we have 3 points on a curve. Okay, so we have stationary point, the point at which dy dx is 0. We have turning point, the point at which a curve is changing the slope from positive to negative or negative to positive. Then we have point of inflection, is the point at which the curve is changing from being concave to convex or from being convex to concave. So we have point of inflection. Now there is a curve in mathematics that looks like this. That is the curve of x raised to power 3. So it's having point of inflection. Stationary point is different from turning point. However, turning point can correspond with stationary point. Okay. At maximum point, we know when you want to find all these maximum points, maximum value, you just need to do test. You need to find the higher derivative of the function. Now, at maximum point, d square y over the x square is less than 0. When you put the function of x, the second derivative of the slope will be less than 0. I will explain this. At minimum point, d square y over the x square will be greater than 0. Let me come again. At maximum point, d square y over dx square will be less than 0. At minimum point, d square y over dx square will be greater than 0. Okay? Now, at point of inflection, I'm talking about this point here, d square y over dx square will be exactly 0, will be equals to 0. Okay? How do we now use this to solve questions? It's very simple. Now, in a question, if you are asked to find the maximum value, maximum point, minimum point, just calm down. This is what you need to do. So the first one is differentiate the function. Find the first derivative of the function. The next step is find the extrema by equating it to 0. So the differentiation, you just equate it to 0 and you solve it. You are going to get two answers for x, the two extreme end coordinates. Okay, when you get them, you will now find the second derivative of the function and you will now substitute the value that you have gotten from step 2 inside your function. Anyone that satisfies this condition, you can use it to get the maximum point, minimum point, and point of inflection. So to better understand this, let's start solving question.
In the next video, we are going to talk about this. We are going to solve this together and many examples on Extrema. Then we are going to look at a rate of change. So make sure you watch the next video. And if you haven't liked this video, kindly like this video, comment your view about this video, share, like, and subscribe to this channel. All right.